Hello everyone, in this video I would like to briefly discuss how can we read the value from this SinCosEncoder encoder from Beckhoff system. This SinCosEncoder encoder interface module, that is a EL5021. Another common used encoder, that is an incremental encoder. So if you need to read the value from the incremental encoder, so you can use the 5151 module. For example, this incremental encoder interface module. The program and the operation to read the value from the encoder from EL5150 or EL5021, they are similar. Because in actual case, I used the 5021. I used this module for reading the SinCosEncoder encoder before. So I will mainly introduce this EL5021, this module. And because it's hardly to get the encoder and the actual hardware together to record this video, please forgive me, to record this video in time, I don't have the actual encoder and actual hardware. But this is a quick demonstration. How can we quickly configure the text into this module hardware configuration? Because basically reading the encoder using this two interface module, we do not need to program too much. Basically, we just need to connect the variable to the hardware and configure the interface module related to your encoder data or configuration. So that's the basic idea. We do not need to program too much. Recently, some friends asked me, do we have a chance to introduce how can we configure the encoder interface? My concern is because I don't have the actual hardware to show, but I used before. By that time, I didn't get a chance to record the screen. So I did hesitate to record video because I don't have the actual hardware. And then I realized this actually the most of the cases will face this problem. They will pre-program first and then get the actual hardware, right? It's really hard to wait till you get the actual hardware and figure out how to program the module. So I think it would be a little bit of value to show, even if I don't have the hardware, but quickly show how can we configure and what the key point to program to read the value from the encoder. So firstly, very important information coming from this Beckhoff information system. From this list, you can find out Fieldbus components, EtherCAT terminals, and then find out this list. And the two key modules we will introduce, that is EL5021 and this EL5050. This EL5021, that is a SinCosEncoder encoder, and this EL5150 incremental encoder. And someone will ask what the difference between those encoders. So the SinCosEncoder encoder is a signal is like this style. And its a signal is a sine cosine wave, and the peak to peak the voltage that is a 1 volt, and it's 1 volt. So it's a signal like this. And to wire this sine cosine encoder using this EL5021, this module, we will wire the sine plus, sine minus, and the cosine plus, cosine minus, and the reference C and the C minus. Some sine cosine encoder doesn't have this reference input. That would be fine. So it only have a 4 wire plus 2 wires, that is the power. And keep in mind the sine cosine encoder, that power, that is a 5 volts, that power. So you can use this terminal to supply the power to the encoder, or you have a 5 volts power supply from outside. Keep in mind the common of this module, of this controller system, that common need to connect to that external power supply. Let's go to find out this configuration data, input data, and output data page. And regarding the configuration data, as we know, for the different encoder, they will have a different resolution. So basically, they will have a 10 bits to 13 bits. When I used my encoder, so that encoder that is a 13 bits. So we need to set as 13. And I will show how we can set this parameter after. And how we can read the value from the encoder. So basically, we can go to the input data. Here, the encoder value, this 6000, this 6011, this is the encoder value, counter value. And there are also some feedback signal. And if we scroll down, here, it also can show some frequency error or amplitude error. especially if your encoder loses power, so this amplitude arrow will turn on. And regarding the output here, so most of the cases we will use this set encoder, and the actual value will go to set the encoder. For example, most of the cases we will use this set bool command, and this actual value for the encoder homing. As we know, both sine cosine encoder and incremental encoder, when we lose the power for that encoder, so the encoder value will lost. When the system reboot, we need a home sensor, move the machine to the home and touch the home sensor, and that moment we set the value to that encoder interface module, so we home the sensor value. Or some cases, when the machine touch a sensor, so that moment you want to latch in this encoder value, so you can use this bool to trigger and latch in the value. And the encoder latched in, so the encoder, you can read the actual encoder from this latched encoder value. And from this 5021, I also have a sample program. But frankly speaking, this sample program looks very complex. The first time when I tried to use this sample program, I was really confused. So personally, I recommend we can use a simple way to implement this encoder. Unless you try to use the program, PLC program, to write a bunch of parameters to this module, to this interface module. So you could try to use this sample program. I will download this sample program and briefly show you what this sample program looks like. So that is this file. Okay, and then let's quickly shift to the EL5150. So that is the incremental encoder interface. So this is a EL5051, this is a wiring diagram. Regarding the encoder, so it can connect the encoder A, B, C 3 channels. And this module also can supply 24, there's a power supply to the encoder. And also it has a gate and a latch, this signal input. And regarding the setting of this EL5151, so we can go to the commissioning under this hierarchy, go to this CoE object description. So same thing, find out the configuration data. For example, this 8013, that is scaling of the frequency measurement, the scaling of the period in the process data, or the resolution value. So those parameters you need to follow the encoder you are using. And to read the encoder value, we can go to the input. And the actual encoder that comes from 6011, this encoder value. And same thing, if you try to home this encoder to set the value, if you try to control, so you can turn on this bit, set encoder value 7003. And the actual encoder value you try to set, for example, this can be controlled by a home sensor. And at a home sensor turn on, you can set 0 or other initial value to this encoder. So you can set the actual encoder value, while this 7011 set encoder value, that is an integer. And the same thing, if you try to use the outside input to latch the value, to record in a short moment what the actual encoder value, so you can read that latched value from this input, 6012. Okay, let's shift to the TwinCAT3 side. Let's see how can we read and how can we set the encoder. Okay, this is the Beckhoff TwinCAT3 software. So I already set up this project, and my PLC project is named PLC Encoder. And to quickly show the sample program we download from EL5021, so we can go to this PLC, right click, add this existing item. I like to quickly show what that example program looks like. The file is named this, so that example program is named EL5021. That is a PLC program here. So let's click this open. This is that example program. So we can expand that and check out the main. So this main code is a P_EL5021. So as we can see, for the new starter and for the new learner, honestly, this looks very complex, but probably you can use some sample codes from this sample project, just for your reference. Okay, so we can see it's very complex, but actually the important, very key line, that is the bottom line, this is the actual input here. So this tag is declared as an input, udent. So this is the actual encoder value. So the motivation for me to make this video, I will create the simple project. I will not use this example project. I will create a simple logic to show how I briefly set up the connection, how we can quickly read the value, do a very simple program. Okay, so let's go to my project, PLC encoder. And let's firstly create the hardware configuration. And I will assume we are using the CX9020 controller, and we will use the EtherCAT eBus. So I will configure the SinCosEn interface module and the incremental interface module. Okay, go to the I/O and right click. Go to the I/O device, add a new item. Click this EtherCAT master. Okay, right click, new item. And let's add this power supply, 2 ampere eBus, EK1200. And from here, right click. So this is the actual hardware terminal. So here, under here, that is the signal module. For example, input, output module, or this measurement terminals. Okay, so let me create this 5021 one-channel SinCosEn encoder. And next, let's create this EL5151 one-channel incremental encoder. So both SinCosEn encoder and this incremental encoder, they are very common used in industry applications. Okay, so let's expand. And then next, so we will declare some important variables. Those variables will be used to connect to this hardware area. Okay, so let's go to the PLC project and go to the GVL, right click, add a global variable list. I will name EL5021. So very important, that is the encoder value. So let's declare the first important variable, that is an encoder variable. That is the encoder value, encoder value. Okay, AT. So because this encoder value will be used to connect to the hardware, the variable tag directly, so that is an input tag. So we will follow this syntax, %i star, comma, udent. Okay, that is the syntax, that is the input. Okay, after this, we will declare two output, for example, the set value and the value we need to set. So firstly, that is the one bool signal, set encoder value, AT. This is and this is the output signal. So that is the Q star. And this is the bool to control that set. Okay, and next, that is the actual value we need to set. Set encoder. That is the actual encoder value, so this dent. Okay, so we could delete this value here, so makes it more clear. This is the command, and this is the actual value we need to set to the encoder, to this module. Okay, other than that, we can name another home sensor, star, bool. Okay, and then I will declare one trigger. So home sensor. Okay, so we briefly declare some important tags here. Keep in mind, all those tags are declared under this EL, this global variable list. Okay, save. And then I will copy this variable list for the 5151 encoder. So I will paste, rename it to 5151. Okay, after we copy this, we'll see the 5151 will have the same variable here. Because when we use this global variable with this attribute here, so we need to use this full name prefix dot this variable. So even if both encoder they have the same this tag name, it doesn't matter because this prefix name they are not the same. Okay, so now let's connect those tags to our actual encoder here. So first let's go to the 5021 and go to the process data. And we will see under here, this area is an actual area we need to connect those items to our variable. So firstly, that is very important. That is the encoder value. Encoder value, that is the udent. So when we double click here, here is used to connect the tag. So far we haven't compiled this project yet, so now it shows nothing. So we need to save and build the solution first. The system will generate those variables, okay? And then let's go to this counter value again, double click. So this time we will see. And because we declare this encoder variable as an input variable, so both input variable will show up here. For this EL5021, so we will connect this 51. So we'll connect this encoder value. Click OK. Once you connect the actual variable, it will show across here. And then let's go to here, set counter. So this set counter, that is a bool signal. So we'll double click. And because this is only one bool signal, so it will only show this bool signal for the Q output. Okay, so I will double click this. And the value for set to this interface module, we will double click and it will show up this udent for output Q. That is the set encoder value. Okay, so we will connect this. After we config, they will show the cross here. And the same thing, let's go to the EL5151. Double click, go to the process data. And okay, here. So then let's go to the counter value. So counter value. Okay, this counter value is a uint. So if we double click this counter value, none of the variable will show up because we never declared the uint before. So we need to go to the 5151, this variable, and change this encoder value to uint. So let's delete this. And the same thing, let's delete this. After we change here, let's rebuild the solution. And then let's go back to the hardware. Double click this hardware, go to the process data, find out here. And then this counter value, let's double click. So you will see this uint that declared as an input, it will show up after we change. So click OK. And then let's go to this set counter, this one bool signal, this is one bit. So double click. So it will show up this B set encoder. This is one bool command. And the actual encoder we need to set counter value. That is a uint. So let's double click. Click this set encoder value. For this incremental encoder, probably you could also need to read this period value. This value, that is a udent. So that will be a similar idea as this counter value. We can declare as an input that date type, that is a udent. Okay, using this way, that allows us to connect the actual tag with the hardware. They join together. This is the Beckhoff style. Okay, and then next things, you will ask where we can set the encoder parameters. For example, for the sine cosine encoder, if we are using the 13 bits sine cosine encoder, where we can set that configuration, then we need to go to this CoE-Online. And keep in mind, so to set those parameters, highly recommend you connect to the actual hardware and download this hardware configuration using this activate configuration and shift this area to online and online change those parameters. And when you change any parameter here, so those parameters will write into this hardware module. Even if you power down and start up, so those parameters, once you set here, the hardware will store those parameters. The parameter will not lost. For example, for this EL5021, as I introduced, to set an encoder parameter, we need to go to the 8000 here. And for the analog resolution, probably you need to set 10 to 13 bits. That totally depends on the actual encoder you are using. For example, my encoder I used before, that is 13-bit. So I will type in the 13. Okay, and I will turn on this enable frequency arrow and enable this amplitude arrow to monitor the encoder status. Again, keep in mind, you need to go online and go online status and set the value. So once you set, those parameters will directly route into the hardware module, encoder interface module. And to check out those parameters, what does mean of those parameters? So you need to go to the information system I just introduced. Check out the configuration data configuration and find out the detailed information here. And another thing that is this, the startup. So if one day this module got a fail, so the customer or end user change one new module. So because those parameters wrote into the module directly, so if you change a new module, those parameters will lost. So you need to rewrite every key parameters right directly into this new hardware interface module. So to prevent this, to automatically write the parameter, so when you change a new module, probably we can use the startup. For example, if I try to write that 13-bit to that parameter, so I can click this new and make sure it's selecting this P point to S, this selection, that is by default, and then find out this parameter I need to write. And at here, double click, write the parameter you need to write. Click OK. And then click OK here. So create this line. So once you configure this line, it shows like this. So once the system got a new hardware and after the system start up, boot up, so those parameters will write into this hardware. So this prevent after we change a new module, all the parameter lost. Another way, you can use a PLC program to write those parameters into the hardware. So you can use the sample program as a reference. Okay, shift to the EL5151. We can find out this CoE-Online. So we can see encoder setting here, 8000. So we can see this, for example, the frequency scaling and the period scaling. So we can set the actual parameter at here for this 5151. Okay, here that is the configuration data. And then how we can read the encoder value and how we can home the encoder value. Let me briefly show how can we program that. For example, let's go to the main. Okay, so to read the actual encoder value, for example, if I try to read this EL5021, and because this input encoder value, we already connect to the hardware directly. So to read this variable, the entire variable, that is the EL5021 dot this encoder value. So this is the entire tag. And if at here we create one internal tag, for example, this is the encoder 1. Okay, we declare that as the udent. And keep in mind that is a local tag. And when we try to use this local tag, we can here encoder 1. So using this way, as we know, this is the actual input directly come from the hardware. and we write into a local tag. That local tag still a udent value. And after this, probably you will do some math calculation. For example, you need to firstly figure out one rotary, so how many encoder value it will run, and use this one rotary encoder value. So do a math, calculate, for example, transfer a degree or transfer to percent value. So that based on your application. Okay, this is the actual encoder value, and how we can write the value into the encoder. So firstly, we can use the trigger signal. For example, let's call this EL5021 dot. So that trigger function block. Okay, so when you type in this left bracket, it will show up the input and the output. So the clock, this is CLK. So this CLK, the signal come from our home sensor. The home sensor come from 5021 dot the home sensor. Okay, do this way. Okay, so this is the R trigger signal. So to use this R trigger signal, we'll assume, so when the home sensor got touched, using that rising edge, we will write a direct value into this encoder. As this is a rising edge, we can use if this rising edge turn on, then so this set encoder signal. And keep in mind here, when I use this set encoder, I assume at this moment the axis is at a standstill. The axis is not moving, so we will keep writing this counter value to the encoder module equal to true. And meantime, so we will set an actual value to the encoder set value. So we will initiate this encoder to 1000. Probably we can add another if within this if, waiting for the motion or the axis at a standstill or the stop mode, and then we write the actual true to that set value command. Once this home sensor go off, so we will reset this set encoder command. For example, then so we will force this command. Okay, this machine leave out of this home sensor. So once this home sensor turn off, so we will disable this set encoder. And in my case, my home bracket could be a little bit long, so allows that home sensor can turn on for a while and waiting for the axis at a standstill mode. And once the axis at a standstill, I can write that set value turn on. So write the actual value. That moment, the axis is a stop. So that stop position is the actual initial encoder value, 1000, the value. And again, because I don't have the actual hardware in my hand, but those code can work because I programmed the similar code before used in my actual project. They are working. So hopefully this is simple code, and this video can give you some idea how we can quickly set up the encoder, how we can connect the input and the output tag, and how we can home this encoder, and how we can read the encoder value. And to read this home sensor, and this home sensor come from the input directly, so we can do this way. We can create another module here, create and a new item, and let's create a digital input. For example, let's create this EL1008 8-channel digital input. And here, find out this channel 1 input, click this link to, so we can link to the home sensor for 5021. So because this home sensor variable was declared as an input, digital input. So, and for the second encoder, same thing. We can click this link to, click this 5151 home sensor. Okay, that is the home sensor input. Alright, I use the first portion as a reference, create a program for EL5151. Okay, those are the entire sample program. After this program, you need to download the hardware, active the configuration, and then hit this login and hit start. So you will read the encoder value. To read the encoder value, actually, this is the first simple way to read the encoder value. Using this way, we do not need any additional license. Another way that is to set up the NC access, and that's under the motion. Using this way, we have to purchase a license, that is the NC license. You are using this encoder doing some closed loop precision control, probably you need to use this motion. That moment, that's become much easier because you can go to here, set up one encoder access. So let me quickly show that. For example, let me add a new item. And that's NC P2P. Okay, and under this access, let's create one access one. So for example, I will name it encoder. So come here, encoder access. So you can create here. Let's click the OK. So this is the encoder access. So here, let me create another module. For example, add a new item. So let me create another 5151. And this time is this. Okay, so let's go to the access encoder. Double click. And at this NC encoder, at here we can link to the actual hardware. For example, let's click. And then it will show up this encoder. So it can connect to this terminal 4. So because the terminal 4 is a spare one, we never connect any tag to this terminal 4. This terminal 4 is here. This is the new added 5151. So if I click this link to, so connect, OK, click OK. So using this way, this access will be connect to this hardware. There's a terminal 4 encoder. Okay. And then you can set up the parameters for this access. Okay, if I click this build solution. So after this, you can find this link to I/O. So this encoder is linked to the terminal 4, 5151. So meantime, if we go back to this EL5151, double click, and go to the process data, and find out here, we will see the system automatically connect to the tag. For example, if we go to the counter value, so this counter value, if we see this right side, so it connect to this date type here. So all those tags come from this new access, that is the NC access. This way, pretty automatic. However, we need to purchase a license, because now if I go to this license here, so we'll see the system will automatically try to need this TF5000, this NC P2P, this license. But using this way, by comparison, if we are doing some simple application, for example, we'll only use the feedback, the position feedback as a landmark, control the motion to a place and stop and go back. Such a simple application, so we can set up the variable just to read the encoder value directly using this simple way. Then we can read the encoder value directly from the hardware. So we do not need to create this NC access, so we do not need to purchase any additional license for that. Alright, that is the brief demonstration for the Beckhoff encoder EL5051 and EL5021. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.